Good afternoon, good morning, depending on which part of the world you're calling from. Today we'll be going over duct sealing as a ECM. So right now things are a little crazy out there in the world, right? So everything from ventilation, safety, health, a lot of these new guidances and a lot of these new protocols are calling for pieces that you'd more or less be running more energy. So ventilation, upping, we're talking about opening up things as we move forward, moving out of the office, back to a safe work environment. So duct sealing at the heart of that, ventilation, energy savings, and obviously a healthier environment. So we are going to be talking about a lot today, and we're joined by Aeroseal's very own Director of Commercial, April Frakes, and Commercial Account Executive, Art Wagner, to go through the process, go through what Aeroseal has to offer, some case studies, energy modeling, the ventilation aspect, really give you guys a well-rounded approach at what Aeroseal is bringing to the table and how we can help a facility be green and clean at the same time. So today's agenda, we've got a lot to cover, so we'll get right into it. As we're going through the presentation, questions are allowed. Please open up the window pane over there and ask them throughout, and we'll get to those towards the end as time permits. This presentation is being recorded and will be available about 2 hours after the presentation, shared out automatically. There'll be a short survey at the very end just to let us know any future content that you'd like to see as we continue down this path and more or less pivot against other factors in the world. So we want to be able to support the industry as best we can. And without further ado, I'll pass it over to Art to go through the Aeroseal process.
Hey, thanks, Billy, and welcome to everybody on the call. I'll take a few minutes to describe what Aeroseal is, what our approach is to a project, what the process is, and what the expected benefits can be to our users. So what is Aerosol? For those of you who don't know, Aeroseal is a proven patented technology that was created by scientists at the Lawrence Berkeley National Laboratories with partial funding from the DOE and EPA. We have more than 20 years of use in the field with over 150,000 residential and commercial applications. So the technology is a safe solution really for any building type. What we'll do is seal HVAC ducts from the inside out, reducing up to 90% of the leakage. Now we do that sealing by injecting a fog of aerosolized sealant into pressurized ductwork to seal air leaks from the inside. It relies on a software-based system that continuously measures airflow and leakage throughout the sealing process. Water-based sealant particles accumulate only where leaks are located, and it completely closes them off. Aeroseal is non-invasive, and it works from the inside of the ducts to locate the seal leaks regardless of duct accessibility, and that eliminates the need to tear down walls or strip off insulation. The system records results in real time, and it stops when desired levels have been reached. Our process is more cost-effective and consistent, obviously, than someone with duct tape and a pail of mastic. That's why we guarantee results and paybacks typically between 2 and 7 years. Now, there are a couple frequently asked questions that always come up, and one tends to be asking for a description of the process on how our installers begin a job. Our teams follow a predetermined schedule that we'll set up with the customer to make sure that the duct sealing doesn't impact building operations at all. In fact, we found that most multi-floor buildings can be treated with Aeroseal without disruption to its occupants. Our project technicians will block off the building's diffusers, grills, and registers and isolate the air handling unit, and then they connect the Aeroseal equipment and a pre-seal test is done. And what that'll do is set the leakage benchmark. After that's been done, we'll inject the sealant And once the sealing's completed, we'll do a post-seal test to measure final leakage. Then a certificate of completion will be generated to measure, verify project results. And April will have an example of that a few slides down. Now, looking at this application FAQ slide, I wanted to point a couple things out to you. Notice the before and after picture. You can see before where there's a pretty significant gap in the ductwork, and then after the Aeroseal sealant has been applied. The interior of the duct isn't coated. The sealant only sticks to the holes, and the sealant will cover a span hole up to 5/8 of an inch diameter or a seam that's 5/8 inch wide. You can see the sealant on the right after it's had a bit of time to cure. It's a little milky white in color. It remains pliable after it's been applied. And I like to tell people that it has a similar feel and texture to the adhesive strip of a credit card that you might get in the mail where it's attached to the paperwork, so it feels that way. The sealant itself is a vinyl acetate polymer. It has the same base that chewing gum has, hairspray, latex paints, even baby pacifiers. It'll keep its elasticity, and it has a life expectancy based on lab testing of over 30 years. There's no VOC off-gassing once it's cured, which typically takes up to about 2 hours. And it's UL 1381 certified and is in ASTM compliance for surface burning, mold growth, and humidity, interior duct burning, leakage reduction, and durability. Also meets NFPA 90A standards, and because the sealant only goes to where there's a leak, we're able to keep usage very low. 1 gallon will typically cover 2,000 to 3,000 CFM of leakage. So why do we use Aeroseal? Well, it's because air ducts leak, and that's no surprise to anyone on the call. There have been multiple studies that have shown that light commercial duct leakage is typically 30% or more. ASHRAE says that 75% of all ducts leak between 10 and 25%. Typical ductwork will lose 25 to 40% of its heating and air conditioning energy. Even newly installed systems experience 10 to 30% of leakage. Now, those percentages are pretty impressive, but it's even more flooring when you get to see how much that actually costs. Berkeley National Labs commissioned a study to find the top 10 building faults by cost and found that duct leakage was top of the list, costing the US almost $3 billion a year. And you'll note by looking at those numbers that that number is 50% higher than the second building fault, which is leaving the HVAC system on when the building's been unoccupied. So it's an amazing amount of money that can be wasted. So facility managers look to Aeroseal obviously to help reduce energy consumption and cost, but in light of the COVID-19 crisis, they're looking for help as well in improving indoor air quality, improving building ventilation, and really in general, they'll look to Aeroseal to help make a building cleaner and greener. Billy?
Yeah, so, okay, at this point, we will hop over to, so we have a short little video here to go through some statistics. The sound isn't working on this, so disregard if there's any sound that comes up, but otherwise we'll kind of roll this and play some statistics and just something to give you a visual.
All right, thanks, Billy. So we've talked about how Aeroseal works, but now we're going to talk a little bit about how your building can be green with Aeroseal in the buildings that you work on every day. So that video just demonstrated how air duct leakage really costs buildings money. And just like that statistic of $2.9 billion a year shows, but what you're probably thinking is, okay, but how do we actually prove how much money our building is losing every year due to duct leakage? And so when Aeroseal was developed, we actually developed 4 different energy models as well to calculate duct leakage and really show everyone on all of your projects how much money can be saved by sealing up the ductwork. As a matter of fact, when FEMP was evaluating how much savings can be done by duct leakage, they put us in their technology deployment matrix. And then the HVAC category, when they ranked everything you could do in HVAC, duct sealants, aerosol duct sealants, of which Aeroseal is the only one, ranked 3. And so you think about it, we're behind boilers and heat pumps because we don't have that overall cost savings of the big money that you can get from boilers and heat pumps. However, when you look at cost effectiveness, the bang for your buck is what I always like to say. We actually ranked higher than that. So in the HVAC category, FEMP said that aerosol duct sealants, basically Aeroseal, is the most cost-effective thing you can do in your building. So I want to talk about that a little more actually. So FEMP actually isn't the only one who's evaluated us for cost effectiveness. If you go to our website, you can see there's been studies done by CEE that talk about the cost effectiveness and the money saved that can happen by sealing your ductwork by Aeroseal. There's been evaluations done by the Navy as well. And so we'd love to talk to you more about if you have any buildings that you want to get evaluated and really run some energy models on, we'd love to do that. And later on in the presentation, we're going to talk about a little bit how that can be implemented and what is done when you have an actual project as well. So let's talk about how you keep your building clean with Aeroseal. So when we talk about why we seal ducts, in the past, the #1 thing that we've talked about is energy conservation. We work on ESCO projects all the time. Energy has been #1. Occasionally, things would come up about indoor air quality or comfort. People complaining about cold rooms at the end of the hall. We've had school projects where kids were wearing coats in the winter, teachers having to talk about fans in the summer. We've also had some indoor air quality issues at certain facilities as well. If you go to our website, you can read lots of case studies where there's been other issues that we fixed. There's an example of a hospital where they had drug isotopes from different drugs, from cancer drugs that were making it through the hospital, and we had to help fix that. We had other issues where there was a morgue at the bottom level of a facility and the odors from that was making it up, and we had to help fix that as well. So indoor air quality has been an issue, but it was definitely not the main focus. However, now that we are living in a world where disease transmission is a huge focus, indoor air quality is something that people are thinking about all the time. As a matter of fact, there are many organizations that are coming out with different guidelines and what we can do on the HVAC side to help prevent disease transmission, virus transmission, what we can do with our HVAC systems to really make buildings cleaner and healthier for all the occupants. Especially now, as a mother, my kids are getting ready to go back to school. Do we send them back to school? What do we do? And now, as we're thinking, I'm sitting in the office for the first time today since March, right? So people are going back to work, and this is a really big issue. So ASHRAE has some guidance for us of that. They're definitely saying that changes to HVAC systems can reduce airborne exposure. So people are really admitting now that this is an issue. ASHRAE is telling us, hey, you want to flush the HVAC system? Do you want to operate the exhaust fans more? And they're telling us as well, you want to run the system on minimum outside air, even when the building is unoccupied. The CDC is saying that you want to run the HVAC longer to enhance air exchange. You want to increase that outdoor ventilation, and you want to open those dampers to reduce or completely eliminate recirculation. Now, I know that there's a lot of energy folks on the line, and when you hear those things, all you're thinking is like ka-ching, ka-ching, right? Like, this is so much money that's going to cost. All these things that we've been doing on the energy side to help make the buildings greener, now that we're trying to make the buildings cleaner, that's going to cost a lot more money. And what can we do to help save money and make buildings more energy efficient and greener, but also help keep people healthy when they're in the buildings? And Aeroseal is one of those few technologies that can do both. So let's talk a little bit about what happens. This slide shows directly about COVID, but really it's about any kind of airborne transmission. In a traditional system, when ducts are sealed, you're trying to bring in fresh air to really lower that concentration of anything that's in that space. So you bring in the blue, the fresh air, and that makes the contaminated air diluted. So that CO2 is being diluted in the space, and everything's exhausting out the way it's supposed to. And really everything in the space is, all of that bad air or the sick air is being diluted out. But what happens when you have leaky ducts? So when you have leaky ductwork, all of that fresh air that you're trying to bring in to meet those ASHRAE standards, to meet all of these CDC new guidelines, is being leaked into the ceiling, basically, and it's not making it into the occupied space. And so all of that dilution that you're trying to have happen into that space, it's just not going to make it. So instead of having all of that fresh blue air make it in so that you increase the dilution, it's really just recirculating that same old air. And then also what's happening is the exhaust is not going to work as well. So when you have exhausted air in a traditional system, you have the exhaust fan on top, and you're trying, this is showing a toilet. When you have the exhaust, it just goes right up and everything bad gets exhausted out. But when you have leaky ducts, it's kind of like a straw, right? So you try to suck everything from the bottom, and it's not going to pull anything from the bottom up when you have leaks in the ductwork. And so everything that's polluted is going to stay in that space. And that's really the problem when we're trying to meet all of these guidelines. So let's talk about those implications of duct leakage right now. So just like we talked about short circuiting when we were talking about energy savings, it's really the same thing that's causing the problems right now with the fresh air. So the fresh air to the return or the exhaust is being short circuited. So it's sent back to the supply fan or being exhausted from the building, and the exhausted air depends on the need for the pressurization or the depressurization. So up to 40% of the supply air that's being leaked never gets to the space. And the duct leakage reduces the concentration of the COVID in the exhaust air. And then so all of this means that you're unable to meet CDC, ASHRAE, or there's Harvard recommendations for healthy buildings, but you're never going to be able to meet that for fresh air in buildings. So So, you think about some of the slides that we had at the beginning. ASHRAE tells us that 75% of ducts leak 10 to 25%. The studies that show light commercials, especially leaky, 10 to 30%, right? So this is something that's widespread. It's not something that is happening in just a few buildings. It's not happening, in old buildings. This is happening all over the place. And so every time that you're opening those dampers, every time that you're running those fans or bringing in more fresh air, that doesn't necessarily mean that it's making it to the space and that you're meeting those requirements that are needed to keep the spaces healthy for those occupants. So let's talk about what we can do to actually implement our solution to make those buildings both clean and green. So Aeroseal has developed a 4-phase process to make it as easy as possible for you to implement this in any building that you're working on. The first is we're going to audit and evaluate. So basically we gather a bunch of data on your site, and before we even come out, we're telling you whether we think this is going to be a good candidate or not. We're going to go out and when we actually do the sealing, we're going to test it and we're going to quantify how much duct leakage is in the building. When we're out there as well, we're going to solve all of your problems. So we're going to tell you in that audit process what needs to happen. If it's just duct sealing, that's great. If there's other issues in your building, we will tell you that as well. So if there's bigger holes than 5/8 of an inch, we will let you know that as well. If we think that there's some cleaning that needs to be involved, any sanitization, anything like that, we will let you know that in that audit process, and then we will be able to do that when we're out there as well. And then that measurement and verification process. So every time we seal up a section of the duct, you'll get a certificate of completion that has that test information that tells you how much leakage was there when we started, and then it has that verification, how much leakage is there that when we're done. So you know exactly how many CFMs we sealed up while we were there. So before we come out, we'll ask you for some information, and this really is the inputs into our energy model. And what that helps us do is really give you an idea of how much energy savings there are in your building and what kind of payback we're looking at before we even go in. The only thing we don't know at this point is the duct leakage, so we'll put in a conservative number, and then you'll be able to go back to your customer and give them a number of what we estimate the savings and the simple payback to be, even before we go out and audit. Once we do go out and audit the building, we'll walk, like I said, we'll walk the building, we'll take lots of photos, we'll create energy models for every air handler. We'll tell you if there's anything additional that needs to happen in those buildings. So if there's any exhaust systems that may need cleaning, if there's any holes greater than 5/8 of an inch that may need repairs, anything else that may need to happen, we'll send over the audit report and give you a call to review that. And then we'll guarantee everything that we said in that level 1 audit report. And the most important thing about Aeroseal and making us a viable ECM is that we have that certificate of completion. So immediately after we seal up each section of duct, we tell you how much CFM was there when we started and how many CFM of leakage is there when we're done. Also, Aeroseal lasts for over 30 years. So this is not something that we have to come out and reapply every time. This is something we do one time and is done. And we get to everything. So this gets to ductwork that's, in areas that normally may have been a problem, but you didn't have any way to fix. And it's after it cures, there's no VOC off-gassing. So after we leave, occupants can go in the next day and they would never know we were there. There's no smells or odors or issues. So now I'm going to turn it back over to Art, and he's going to talk about a few case studies, and then we're going to go to the Q&A.
Thanks, April. We're often asked what opportunities look like good fits for Aeroseal, and I tell people who ask me that we tend to focus on large buildings, typically greater than 8,000 square feet, of those with high occupancy, high outside air, high static pressure. Older buildings are always good candidates because of higher than average leakage and the comparable cost of replacing ductwork, right, as compared to aerosealing. We also look for buildings with dedicated exhausts like dorms, labs, multifamily units. Aeroseal has experience with all of these categories, including federal and military, both domestically and abroad. Healthcare, obviously, right now is very important to all of us, not only from a hospital environment, but from assisted living, nursing homes. It's something that is a very good opportunity, I think, for all of us. Higher education facility managers right now have their hands full, as April mentioned, with the fall coming up and students going back into class. The opportunity to use Aeroseal and help their indoor air quality is really pretty substantial. Multifamily and hospitality applications are good. Hospitality meaning hotel, obviously a lot of opportunity there to improve air quality. And critical applications too are becoming more important. We've had quite a few pharmaceutical examples in clean rooms. And of course, there's a myriad of light commercial applications as well. Now, we wanted to spend time looking at a couple specific applications. The first is a case study that was from an office building in Washington, D.C., and we partnered with Sodexo on this project. It was a big building for us to seal, 12 stories, almost 1 million square feet. And their primary issue was anemic airflow. Only 50% of the treated air was reaching their endpoints. Once Aeroseal was introduced and completed, we had an 83% reduction in leakage and over $100,000 in annual savings that provided a really aggressive payback of 1.5 years. And I think even more importantly for the 4 people that were working in that office building at the end of the lines, they had quite a bit better air quality. The next case study is the Clinton Prairie School District that's in Indiana, and there we partnered with JCI for a $4.7 million energy performance contract. Our audit and pre-seal analysis showed that there was over 19,000 CFM of leakage, which was reduced to under 800 CFM after our application. The job lasted 7 days. We didn't do any disruption with the facility as we worked off hours. And once completed, the project documented a 96% reduction in leakage, which exceeded the initial performance goal and actually qualified the school for custom energy rebates. And the last case study we'll go over is the Federal Bureau of Prisons. They needed to meet some strict energy efficiency and system performance requirements. We had a significant reduction in leakage, which was important to the FBOP here because they were looking at replacing their ductwork system completely and were able to use Aeroseal as an alternative. They had $140,000 in annual energy savings, and we finished the work 6 months ahead of schedule.
Great. Well, thank you. And for everybody in the audience, just to touch base, those were 3 case studies. We have many of those up on our website and everything, and we just recently did a refresh. So if there's any additional applications out there, I mean, we've been in a lot of buildings, as Art alluded to earlier, with 150,000 plus projects. But yeah, if there's anything additional, they're up on the website and they're there for you guys to view. So now we'll hop into the fun part and talk a little bit about what you guys have to add, or what questions the audience would have to share. So again, just to reiterate, the question box is open. Feel free to write in and we'll get to those. And we're a little bit ahead of schedule, so we should have plenty of time to go through. But we'll start off. Carrie would like to ask, or is asking, does Aeroseal recommend that the ductwork be cleaned according to NADCA standards as part of this process? April?
Yes. Yeah, so as long as there's not more than 1/8 of an inch of dirt or debris in the ductwork, ducts do not need to be cleaned prior to Aeroseal. So if we're doing a project where it's the supply ductwork, the majority of the time it does not need to be cleaned. If it is an exhaust project, most of the time it does. So it just depends on that. But of course, we always recommend NADCA standards, and that's part of our recommendations. I know that a lot of our service providers are duct cleaners and do a great job with that. And like I said, during the audit process, or if you're working with any of our service providers out in the field, we will let you know whether duct cleaning is required or not. But like I said, if you're doing a supply ductwork, as long as it's not more than 1/8 of an inch, or any ductwork, honestly, cleaning is not required.
Perfect. Greg is asking, so with a building with induction units, would they be good candidates for Aeroseal? He sees the benefits would be large in a high static fan system, but the labor seems like it would be very high to ensure all the induction nozzles are sealed, removed prior to the application.
Yeah, I think that's probably, you're right. Buildings with high static are the best candidates. Anything like an induction system or anything like that, if you want to send us over and have us evaluate it, we would be willing to do that. We look at different kinds of systems all the time. Higher static pressure, anything that's bringing in a lot of outside air, those sort of things bring in the best bang for your buck for sure on the energy side. But it depends on where you are in the country as well, what kind of systems we can do. You know, a project that may not go in the Pacific Northwest because of lower energy cost may be a great project in the Northeast. It just depends on where you are and, you know, what kind of, if it's prevailing wage, that sort of thing. So that's why we love for you to send us over projects, and we'll be happy to evaluate that for you.
Great. Gaurav is asking, so we touched a little bit about the performance contract. I think Art talked about that on the Clinton Prairie. So for a performance contracting estimate, how much initial leakage percentage should be considered for a guaranteed energy saving contractually?
Yeah, so we go out and we audit the buildings, and just like I said before, it depends on where you are in the country to what makes sense for a project to make it go from an energy perspective. We've had ESPC contracts go with as little as 5% leakage in areas with very high energy costs, but in some areas of the country we need 10 or 15% leakage. But our auditors in the field will definitely go out and audit and determine how much leakage is there during those audits, and we do that for free. So don't hesitate to reach out to us, and we will come out and give you an estimate on what we think the leakage amount is and what the payback is. I would tell you that our paybacks are usually between 4 to 6 years, and that varies depending on, like you said, leakage amounts and energy costs. Like I mentioned before, different prevailing wage rates, that sort of thing. So every project is different. And like we mentioned before, higher static pressure, those things matter as well. So with so many different levers in projects, we like to really evaluate them. But like I said, on average, probably 4 to 6 years is our payback on most ESPC contracts.
Okay, there's a couple questions in relation to the case studies. So the payback for, Derek would like to know the payback for the Federal Bureau of Prisons. I think it was on there, but do we have a payback on that, or was there a relation to that study?
The payback for the Federal Bureau of Prisons, I believe it's on the actual case study. I think it was right around, I want to say like 7 years, but I think it's on the larger case study that's on our website. The great thing about the Federal Bureau of Prisons that Art didn't get into is that they thought they were going to have to replace that ductwork. So we had to do manual repairs and cleaning along with duct sealing. So that payback includes all of those, not just the Aeroseal. So they had a price of about $5 million to completely replace all the ductwork in that building, and they were able to avoid that as well. And of course, our payback doesn't include any of that and none of the cost avoidance. It's just a simple payback number. However, I would say that we were able to, it's between 6 or 7 years, the payback, but we were also able to provide them with the cost avoidance and really help that project go by being able to just do some small manual repairs on the duct, clean it, and then do Aeroseal. We were really able to salvage that ductwork, which really helped them keep that project because they weren't able to put in that cost of replacing all the duct and doing the other things that the customer wanted. So we were really excited to help them make that project work.
All right. The Mark is asking another case study question. So the energy savings stated on the case studies, were they for only fan energy savings or overall savings from other sources, or how are they factored?
Yeah, so there's 4 things that we talk about when we talk about savings based on Aeroseal. There's fan energy savings. There's heat reduction savings from turning down the fan motor. There's outside air savings, both in the summer and in the winter. And then there's a peak demand savings if they have peak demand charges. So if anyone is interested in reviewing our models a little bit further, or would like to see the white papers that go along with any of our models, we would love to share those with you. The great thing about our models are that we share those with anyone. We don't hold those or make them proprietary. All of the formulas are completely unlocked and open for everyone to see. And we share all the white papers and formulas and everything with everyone. So if anyone would like to take a deeper dive into those energy models, just shoot me an email afterwards or give me a call, and we'll set that up, because we like to explain those and make sure that everyone is comfortable with those models as well.
Great. We have a question in here about interpreting the refrigeration savings on a chiller. How do we interpret those, or do we have a good answer on that?
Yeah, so we don't. We only do the air handler savings. So like I said before, we take savings from the fan energy. We take savings from reducing the amount of outside air. We take savings from the reduction in fan heat from the fan motor, and then the peak demand. So that's all we're taking into consideration on our models currently.
Okay. Joseph is asking, are there any precautions or complications if there are retrofits or add-ons to an existing sealed system? I would assume that it just means that the additional pieces need to be sealed, or the additional, I'm not fully sure that was all I got out of it. So does that click with one of you?
Yeah, I don't know exactly what he's asking. If a system is sealed already, there's no issues. I don't know. I guess I don't know what he's asking. So maybe if you want to type in some clarification, or if maybe we answered it with another question, I'm not sure.
Yeah. All right, I will wait. Joseph, if you'd like to type that in, we'll move on to Charlie's asking, can you seal shafts that are subducted?
Yes. Yep. So the only thing that we don't seal is kitchen hoods. So no greasy kitchen hoods. We do not seal those, and we also yeah, that's the main thing that we don't seal. Art, can you think of anything else that we stay away from?
No, I can't. I think that would be the only one that typically stands out.
Yeah. Oh, and then also exposed ductwork. We typically, if it's like in a gymnasium or a natorium, you typically don't get the energy savings from that because it's leaking, the air is leaking into a conditioned space. So we typically don't seal those as well.
Charlie's also asking, do you charge a fee for the initial evaluation, or is that treated like a sales call?
Yeah, so we do not. We do all of that at no cost.
Great. I'm just gonna do a one class little swipe through and see. Okay, so what's your experience with pre-insulated foam ducts in Aeroseal's use?
Yeah, so we do fine with any kind of insulated duct because Aeroseal only goes to where the holes or gaps are. There's no issue with insulated duct or anything like that. The only thing is that Aeroseal is not an encapsulant. So if you have places where the foam is tearing off or issues, we're not going to solve that problem. We're only still going to go where the holes and gaps are. So just keep that in mind. But yeah, we can seal up any kind of insulated duct, even foam duct.
All right. That looks like the last of the questions that have trickled in so far. So if there's any additional ones out there, I know we're a little early on the time. Actually, here, Greg's got another one. So could a new construction duct installation forego traditional mastic duct sealing entirely if Aeroseal were performed to afterwards? Is this more or less cost effective than mastic, basically?
Yeah, it definitely can. And there's been time studies that show that Aeroseal is effective in new construction as well. So it's a great alternative. And then also because we're testing before and after, you have that ready as well, which also is a benefit. So we have information on that, and we'd love to work with anyone who's interested in any new construction applications. We are looking for partners with that all the time, and Art would be a great person to talk to about that as well. One thing I would like to add is that I know that a lot of things that people are doing now to make your buildings ready for occupants and keep everything green cost a lot of money. You think about, leaving you're bringing in more fresh air costs more energy. Bringing in higher grade filters costs more money, that sort of thing. And what we're really excited about with Aeroseal and what we can do to help with this virus is that Aeroseal can actually help make your buildings healthier, and they can help save energy. And we really are excited to keep people healthy, but also help keep buildings green. And we would love to help do that in any way we can for any of these projects, and are willing and able, both Art and myself, to evaluate any projects that you have, anything that you're just not sure about, think may be an opportunity but aren't quite sure. Don't be shy, send it over and we'd love to look at it. So.
Yes, definitely. So April's information is right up here. We will follow up with any of the additional questions that trickle in. There is a survey again after this, so feel free to go through the presentation, rate, let us know how we did, let us know future topics you want to hear about. Anything that you guys can provide us, especially during this time, to better support you. That's our end goal. So unless there's any final words or anything, we'll go ahead and close out. And again, we will follow up personally with anybody else that has additional questions. So I appreciate it. April, Art, anything?
No, sir. Thank you.
All right. Thank you, everybody, and enjoy the rest of your Thursday.